Welcome to today's chemistry lesson. And in our lesson for today, we'll be talking about the periodic table and the electronic configuration. So I'm sure we are all familiar with the periodic table, which basically shows the elements that are put in arrangement, or rather in accordance of their increase in what? The number of protons there. So we start from hydrogen there all the way until it goes to those other elements. So now, this periodic table is divided into groups and periods. So basically we know to say these columns that we have, these are the ones that we are calling the groups. Then the rows, these ones, these are what we are calling the period. So on the groups here, we know to say we have 8 groups. So we have the first group, the second group, third, fourth, fifth, 6th, 7th, and the 80th group, which is considered to be group 0. Then on the periods here, we have also we have 7, where we know to say in the first period we only have hydrogen and the helium. Then they continue like that until we reach the last period, which is that one there. So now, what do these things tell us about an element? So the period and the group 1 is going to give you the position of an element. So if we say this element is in group 4 and period 3, we know to say an element that is in group 4 and period 3 is this one here, which is what? Silicon. Because we know to say we are going to count 1, 2, 3, which is the period. Then the group, it is what? Period 4, which is there. So this is the position of silicon, which is basically in group 4 and the period 3. But now, what else do those things tell us about the element? The group and the period will also give you the number of electrons in the outermost shell and the number of energy levels, or rather shells, that element has. So as we write the electronic configuration, we'll be referring back to this, because the number of energy levels will be determined by the what? The period in which this element belongs, and then the number of electrons in the outermost shell will also be determined by the what? The group. Because we know to say on the periodic table, all the elements that are placed in groups, they share the same properties, or rather characteristics, or rather in other terms we can say they behave the same. So coming to the electron configuration, we know to say the electron configuration basically is just the arrangement of electrons in the shells of an atom. So that one we can say it is the arrangement of electrons in the shells of an atom. So when we show the arrangement of electrons in the shells of all the atoms that we are seeing here, meaning we've written the what? The electronic configuration. So now, to determine the electronic configuration of these atoms that we are seeing here on our periodic table, there is a simple formula that we use, which is basically 2n squared, where we know to say this n stands for the shell number. So this n, we know to say it stands for the shell number. So let's take, for example, we are having an atom which is X. This atom X has got, let's say, 4 shells, like that. So let's say this is the first shell, this is the second shell, this is the third shell, and this is the fourth shell. So in order for us to determine the number of electrons that are going to go in each shell, we are going to use this same formula here, where we know to say 2n squared, where n is the what? The shell number. So meaning in the first shell of this one, we know to say the first shell on n there we're going to replace with what? 1. Because the shell number for the first shell is what? 1. So we are going to say 2 times 1 squared, which is going to give us what? 2 times 1. Because 1 times 1 means 1. So this will be equivalent to 2 times 1 we get 2. So meaning in the first shell, 2 electrons are supposed to go there. If we follow the same procedure, in the second shell, we are going to have what? 2 to the power n squared. So meaning this will be 2. The second shell, we are going to put 2 squared. So this will be 2. 2 times 2, it is what? 4. Because 2 squared means you are multiplying 2 by itself 2 times. So this will be equivalent to 2 times 4, we are going to get what? 8. So in the second shell, we are going to have 80 electrons. If we continue in the same arrangement like this, we are going to come up with something like this, where we're going to say in the first shell we need to have 2 electrons, 8 electrons, 18, 32 until we reach the 5th one. They will still continue going if the number of electrons are still available. So we can continue going just like that, but using the same ideology. So now, how do we write the electronic configuration of an atom? So following this knowledge here, we know to say following this knowledge, we know to say in the first shell we need to have 2 electrons. In the second shell we need to have 8 electrons. In the third, 18 until we go just like that. So if we had to pick an element from the periodic table, let's say for example, an element which is fluorine. So fluorine, this is an element with a mass number of 19, and it has got 9 protons. So yes, the number that is on top, this is the mass number. The down number there, it is called the number of electrons, or rather the number of protons, because in a neutral atom, the number of protons is equivalent to the number of electrons. So how do we write the electron configuration for fluorine? To begin with, we are going to start with a symbol, which is F. After we write the symbol there, then now let's ask ourselves, how many electrons do we have there? We have 9 electrons. We have 9 electrons in this atom for fluorine. So in the first shell is supposed to have how many electrons? 2 electrons. So we are going to put 2 electrons there. So from 9, how many electrons are we remaining with? We are remaining with 7 electrons. The second shell should have how many electrons? 8 electrons. But now, the electrons that we are remaining with there are what? 7, which is not reaching to what? 8. So as a result there, we are just going to write the remaining what? The remaining electrons, which are what? 7 electrons. So if we go back to what we are talking about, the group will give you the number of electrons in the last shell, or rather in the outermost shell, and then the period is going to give you the number of shells, or rather the number of energy levels. So here we know to say fluorine, this one is in what? Period 2. Why? Because it has got 2 shells. The first shell which has got 2 electrons, and the second shell which has got 7 electrons. Then what is its group? Its group is what? 7. Why? Because it has got 7 electrons in the outermost shell. And then if you follow this same ideology where you say the period is 2 and the group is 7. If we go on the periodic table here and check an element which is in period 2 and group 7, we are going to find that your fluorine is there. If we have to pick another element, let's say for example it would be calcium. Calcium has got a mass number of 40 and 20 protons. So here we know to say the electrons are what? 20. So how do we write the electron configuration? So to begin with, we write the symbol, which is calcium. Then now, in the first shell should have how many electrons? Should have 2 electrons. So when you write 2 electrons there, From 20, how many electrons are remaining? We are remaining with the 18 electrons. The second shell should have 80 electrons. The question that should come is, do we have 8 electrons in the remainder there? Yes, we do have 8 electrons. So we are going to write 8 electrons there. So from this 18, we are going to remain now with what? 10 electrons, because we've removed the 8. Then if we go in the third shell there, the third shell should have 18 electrons. But now the question is, do we have 18 electrons there? No, we don't have, because we are remaining with what? 10. So now the rule here is that since the next shell is supposed to have 18, and then we don't have 18 electrons, we need to check in the preceding what? Shell, if the number of electrons that are supposed to be there can be found in the remaining electrons. So since the third shell is supposed to have 18 electrons and we don't have 18 electrons, how about in the second shell? How many electrons are supposed to be there? 8. Do we have 8 electrons there? Yes, we do. So we are going to write 8, comma. So if we remove 8 there, we are remaining with what? 2 electrons. So the next shell here, which is the fourth shell, is supposed to have 32 electrons. But the question is, do we have 32 electrons there? No, we don't have. We go to the preceding shell, 18. Do we have 18 electrons there? No. We go back to the preceding shell. Do we have 8 electrons there? No. So meaning we are going to write the remainder, which is what? 2. So meaning there we know to say calcium has got how many shells? 1, 2, 3, 4. So meaning it is in period 4. And then what is its group? The group here is going to be what? 2. Why? Because it has got 2 electrons in its outermost shell. And for sure, if we go and check on the periodic table there, we are going to find to say that is the arrangement that is happening. So maybe we pick the last one. We pick the last one. Maybe let's say rubidium. If we pick an element which is rubidium, this is 85 as a mass number, and then it has got 37 electrons. So we know to say the number of electrons there, it is what? 37. So the first thing that we are supposed to write here is the symbol. So we write rubidium as a symbol like that. Then now we ask ourselves, how many electrons are supposed to be in the first shell? So in the first shell we need to have 2 electrons. Then from 37, how many are we remaining with? We are remaining with 35 electrons. The next shell is supposed to have how many? 8. Do we have 8 electrons there? Yes. So we are going to write our 8 electrons there, then comma. So if we remove 8 electrons from 35, we are going to remain with the 27. Yes, 27 electrons. So now, the next shell here is supposed to have how many? 18 electrons. The question is, do we have 18 electrons there? Yes, they are there. So meaning, we are going to write 18 electrons. So if we say 27 minus 18, we are remaining with 9. So meaning we are remaining now with 9 electrons. So the next shell here is supposed to have 32 electrons. But the question is, do we have 32 electrons there? No. We go back to the preceding what? Shell. Do we have 18 electrons there? No. We go back again to the preceding shell. Do we have 8 electrons there? Yes, we do. So meaning there we have 8 electrons. So we are going to write 8. Then if we say 8 minus 9 minus 8, we remain with 1 electron. So now the fifth shell there is supposed to have 50 electrons. But do we have 50 electrons there? No. We go to the preceding shell. Do we have 32 electrons? No. Do we have 18 electrons? No. Do we have 8 electrons? No. So meaning we are going to write the remainder, which is 1 electron. What does this tell us about the element rubidium? Rubidium, we know to say it has got how many shells? 1, 2, 3, 4, 5. So meaning the period for rubidium is what? 5. And what's its group? The group there is what? 1. Why? Because it has got 1 electron in the outer shell. And if you go on the periodic table there and check rubidium, yes, it is in period 1, 2, 3, 4, 5, and the period there, and the group is group 1. So basically, that's what we had for you today on how to write the electron configuration and how to determine the group and the period from the periodic table and also from the what? From the electron configuration. Make sure to join us in the next lesson now, where we'll be talking about drawing electronic structures now. After you write the electron configuration, now how do you then draw the electronic structure? Thank you and see you next time.